In this video, we're going to learn to count elements in subsets of two-set Venn diagrams. So this is an apply problem, so let's read the given information. A bag of marbles contains blue and white marbles. So the marbles are either blue or they're white. Each marble is labeled with a number between 1 and 5. Okay, so we have the marbles, they each have a color and they each have a number. The Venn diagram below gives the counts of the marbles based on whether they are blue or labeled with an even number. And now we're asked to find the different amount of marbles in each subset. Okay, so notice here this represents the blue marbles and this represents the even marbles. That's how we're choosing to label them. But notice that, let's get a pen. Everything is either blue or not blue. And in this case, not blue, since there are only blue and white marbles, not blue is equivalent to white. That's not always the case. There could have been blue, white, and red marbles, and then not blue could be either white or red. Similarly, the number that it's labeled with, here we're counting the ones specifically that are even, but if they're not in this circle, they're not even, and not even is equivalent to being an odd number marble. Okay. So using this information, let's find how many marbles are in each of these sets. So how many marbles are blue? Okay. Well, there's two regions corresponding to blue, this one and this one. These are blue and not even, these are blue and even, and we'd include them both. Okay, it doesn't say anything about the even or oddness. Okay, so we're just concerned with blue, and we sum up the two disjoint pieces. Next, we're asked how many marbles are white. Well, if they're white, again, that means they're not blue. Okay, so we don't see white listed here, but white implies not blue. So that means not these two regions. So we'll leave these two out. Here, you're even and not blue, or even and white. Here, you're not even and not blue, so you'll be white and odd. So we'll add up these two regions, and 7 plus 11, that's also 18. That's a coincidence. Next, we're asked how many marbles are there altogether. Well, remember these are disjoint regions, so there's no overlap, so we can add them directly by adding the four quantities. So there are 12 plus 6 plus 7 plus 11. And let's see, 12 and 13 is 25, 35 and 1 is 36 marbles altogether. Next, we're asked how many marbles are blue and labeled with an even number. Okay, so since it's and its intersection, it must be both blue and even. Well, here's the blue circle, here's the even circle. The intersection is the piece where they overlap. So there are 6 marbles that are blue and labeled with an even number. Next, we're asked how many marbles are white and labeled with an odd number. Let's use a different color. Okay, so now if they're white, that means they're not blue. So these marbles are white, and means that it has to be both. So since these are the even white marbles, these are the odd white marbles. Okay, so there are 11 odd white marbles. And finally, we're asked how many marbles are labeled with an odd number. So remember, odd is the same as not even. So let's look at our diagram. Okay, these are the two disjoint pieces that have even marbles. So everything outside this must be an odd marble. So here it's blue and odd. There are 12. Here it's even, white, because it's outside the blue. It's white and odd, so there are 11 of those. And 12 plus 11 is 23. So there are 23 marbles that are labeled with an odd number.